All right, so let's look at some nice properties of logs. Okay, so we have this nice property that says log base b of b equals 1. All right, so why does this work? Well, b is the same thing as b raised to the first power, so b to the 1. And so what's happening? This is actually a composition of two functions. The function on the outside is log base b, and the function on the inside is b raised to a log. So we have a log composed with an exponential. Well, these two are inverse functions. Whenever you compose inverse functions, you get out exactly what you put in. Well, we put a 1 in, so you get 1 back out. So it makes it seem like these things cancel. Log base b and b with an exponent, it looks like these cancel. All right, let's look at the next one. All right, log base b of 1, well, equals 0. Well, if you rewrite this in exponential form, all right, we have b raised to the 0 equals 1. So that's why this is true. Also, on our graph, when you plug in 1, you get 0 as your answer. So 1 and 0 go together with logs. All right, and so we can generalize this for all of our logs, so we don't have to use 1 here. So log base b of b to the x, well, that's just x because these work similarly like canceling out because we're composing two inverse functions. Here we have our exponential on the outside, our log on the inside, so then you're just left with x. So we're going to practice doing this a lot. Okay, so we're going to evaluate the common and natural logs. So remember, common log is just regular log, log, and it has a base of 10. Natural log has a base of e. So we're going to see how these two things work together and help us solve these problems. All right, so this is the same as log base 10, but I'm going to rewrite 100,000 as 1, 2, 3, 4, 5 as 10 raised to the 5th power. Okay. All right, so let's figure out what this is. So we can call this x. All right, so that means our base is 10, our exponent is x, inside we have 10 to the 5th. So that means our x should be 5. Another way of looking at it is, oh, we have log base 10 on the outside, and we have 10 raised to the 5th on the inside. Log on the outside, exponential on the inside. Well, it works like canceling, and 5 is our answer. Okay, let's do another one. We'll do the shortcut. All right, so here we got log, which tells us log base 10. This time we have a decimal with 1, 2, 3 decimal places being moved. So this is the same thing as 10 to the negative 3. All right, and so we can think of it as we got a log base 10, exponential base 10. So our answer should be negative 3. And you can rewrite this in exponential form just to make sure that our answer is going to be negative 3. All right, so then let's look at this one. Remember, this is log base e, e to the 4th. So we have a log base e composed with an exponential base e. So our answer is 4. Then finally, natural log of 1 over e, that's log base e. Here, I don't want a fraction, so I'm going to do it as e to the negative 1. Log base e composed with an exponential with the base e, so our answer is negative 1. Okay. All right, so let's talk about graphing quickly. So we have two cases. So here, we know this is familiar. This is our exponential function. Exponential with a base b, we see that it's increasing, so we know that our b is greater than 0. So this is the graph for b, greater than 1, where our base is greater than 1. Here, our exponential is decreasing, so we know that our b is a fraction. It's between 0 and 1. So let's talk about what these log functions look like. So here, my blue one, that's exponential, and then this pinkish one is the log. And oh look, they're symmetric about the line y equals x. That means they are inverses. All right, and so here, this is our exponential. Here is our log. These are also symmetric about that line, so they're inverses. And so graphing logs can be very difficult because the values aren't nice, and you can't plug log into your calculator. So when we graph them, what we're actually going to do is graph or think about the exponential function and then just switch x and y, and we'll have the log function. So let's talk about how to do this. So number 8, it says on these two graphs, we are going to graph log base 2 of x as well as log base 1/4 of x. So let's start with log base 2. What is the inverse function that goes with log base 2? Well, 2 to the x, base 2. So this is the inverse function that goes with log base 2, exponential with base 2. And we definitely know how to plot points on this, right? So when x is 1, we got 2 to the negative 1, that gives us 1/2. Oh, sorry, negative. When x is negative 1, we get 2 to the negative 1, which is 1/2. I'm also going to do 0 because 0 gives us nice things. So when we plug in 0, we get 2 to the 0, which is 1. And then when you plug in positive 1, we just get 2. Alright, so we know how to work with exponentials now. But now we want to use a log, which is the inverse. And how do we find inverses? We switch x and y. Okay. So for this new table that we're going to use to graph, we're going to use these same points, but we're going to switch x and y. So instead of using negative 1 and 1/2, I'm going to use 1/2 and negative 1. And then 1 and 0. And then 2 and 1. And so that's what I'm going to be graphing. Alright, so there's one more piece that I want to graph, or I want to talk about before I do the graph, is the asymptote. So this one has an asymptote. Does anyone remember where the asymptote is? It's at y equals 0. So that means, where would the asymptote of our log function be if we're switching x and y? It'll be at x equals 0. Alright, so I'm going to graph this function. So I'm going to do my asymptote first because that always helps me. X equals 0, so this is our line. We will never cross this line when we're graphing our function. Alright, and so I'm going to graph x equals 1/2, y equals negative 1, and then 1 and 0. We expect to have that point, and then 2 and 1. Alright, so then we connect. We're going to go up like that. And also we're just going to get closer and closer to this asymptote without crossing it. And that is the graph of this logarithmic function. So this is the graph of log base 2 of x. Okay, so let's do the next one.